Okay, let's have a look at this question 9 from 2021 Living Cert. This question talks about exponential equation, derivative and chain rule. Now, if you are in the 5th year and you have done logs, which most likely you would have, this question, part A and part B, will be something applicable to you and something that your teacher could use on the summer exam or Christmas exam. But then part C and D will be specifically for the 6th year because calculus derivative, that comes in the 6th year. Okay, so let's have a look. A cup of coffee is freshly brewed to 95 degrees Celsius. What does that mean? Well, we understand cup of coffee. Where do we make cup of coffee? Well, let's think about our kitchen. There is a coffee machine, or it's a coffee in the, I don't know, French press, whatever you do coffee in. It's brewed, meaning that when you put hot water into it, the temperature of that coffee is 95 degrees. The temperature T in degrees centigrade of the coffee as it cools is given by the formula. Why is it as it cools? Well, obviously, if you think about it, you make the coffee, you pour the water 95 degrees. That's the temperature of the coffee once you pour the water. And what happens next? Well, the coffee will be slowly getting colder, isn't it? So that how that temperature is going down is expressed by this function, where A is a constant. That means that is a number, and always when you have an equation and in the beginning of the question, and if in that equation you have a letter that represents the number, the first thing you will have to do is to find the value of that letter, and T is measured in minutes from when the coffee was brewed. Okay, so let's have a look at that. And here I will as well say to you, always just pause for a minute and think about the two letters that are represented in here. Because this side of the equation we have capital T, and this side of the equation we have small t. And this is because every function is between the two axes. So in this case is the capital T and a small t, so our x and y, really. Okay, and we are saying that T represents temperature of the coffee, so we are saying temperature of the coffee, and that will equal, A is a number, so we're going to find the value of it, multiplied by e to the power of 0.0881. T is what? Time measured in minutes. So that means here we're going to be putting number of minutes and then plus 20. Okay. So let's see, what do we have to do? As I've told you, show that A is 75. First thing, basically, they are saying, well, find the value of A. So if they are telling us finding the value of A, that means they must have given us some information that has to do with number of minutes and temperature at that number of minutes. So what information have they given us in the beginning of the question? They said here, 95 Celsius. That's the temperature. At what time after coffee was brewed that 95 we have? Well, it is at brewing time. So that means 95 will be at time 0. No time has happened yet. No minute has passed. We have put the water in, and that's it. That's that moment. Okay, so 0 in place of number of minutes. That means that all of that power, value of all of that power is 0. Any number taken to the power of 0 has a value of 1. 1 multiplied by A will be A. So really what I have this side of the equation, I have 95. Here I have A. And then I am left with plus 20. I want to find the value of A. What do? I take that 20 to the other side of the equation. What happens when I take a number to the other side of the equation? I change the sign. So from plus 20 becomes minus 20. So 95 minus 20 is 75 indeed. So yes, A equal 75. So now we have the full equation. Now we can say that the temperature of the coffee equal, change the color, 75 multiplied by e to the power of 0.081 multiplied by number of minutes and then plus 20. Okay, let's have a look at the next part of this question. So explain why the value 20, what, not why, what the value 20 in the formula represent in the context of the coffee cooling. In the context of the question, so what's happening? The coffee is standing, is being brewed, is in the kitchen, and then what's going to happen is that that coffee is going to get colder and colder and colder. Now, can that coffee, I don't know, reach temperature of minus 30? No, it's not going to reach temperature of minus 30 in our kitchen, isn't it? Unless we are living, I don't know, in Antarctic pole or somewhere like that, and even then we wouldn't be able to live in the temperature of minus 30. So no, it's not going to reach that temperature. The temperature of surrounding will stop that process, isn't it, of cooling. And that's what that 20 is. 20 is a constant here. That value will change, but 20 is not going to change. 20 is a constant value of temperature, because remember, all of that, remember that we have equal sign in between them. This side is temperature of the coffee, and this side is temperature of the coffee as well. It's just this side is telling us how to calculate it. That's all. But both those sides represents temperature of the coffee. So all of that in the temperature of the coffee, we have a steady element of 20. That means that is the temperature of the surrounding. Okay, next part. Find the decrease in temperature of the coffee 10 minutes after brewing. Give your answer correct to the nearest whole number. So what is that we are looking for? Find the decrease in temperature. What does the word decrease mean? It's something that goes down in value, isn't it? So what is that thing that is going in value here? Well, we are talking about decrease of temperature. So what's happening? Well, at the beginning, temperature of the coffee is what? 95, and then they are seeing 10 minutes after brewing, and then 10 minutes has passed, and then there is a different temperature here, isn't it? So we know that coffee will be going down with the temperature. That's why we're talking about the decrease. We are not talking about the increase. So that difference between the two we'll find. How do we find the temperature of the coffee? Well, that's where we have this formula, isn't it? We are looking for temperature of the coffee, therefore we know the time, the number of minutes, and we do 10 minutes. So we are saying, therefore, the temperature of the coffee when T will equal 10. So that means it will be 75 multiplied by e to the power of minus 0.081 multiplied by 10 plus 20, and all we do, we put that in the calculator. 75 multiply alpha e power minus 0.081 multiplied by 10, come down plus 20. So 53.36. 53.36. Now, does that give us the answer? Is that decrease? No, decrease is the difference. Decrease is the difference between those two values. So 95 minus 53.36. So that is 41.64 to the nearest whole number. So 6 will go plus 1 here. 42 degrees is the decrease that we are looking for in temperature. Okay, next part. So our function t, again, gives the temperature of the coffee at time t, okay? If the ideal temperature to drink coffee is 82, find the time to the nearest second that it takes for the coffee to reach this temperature. What are we looking for? Time. Well, if we are looking, where is our equation? If we are looking for the time, if we are looking for number of minutes, that means that what? They have given us the temperature of the coffee, and they said what? 85. Okay, so that means temperature of the coffee is 80, not 5, sorry, apologize, 82, isn't it? 82 equal 75 multiplied by e to the power of 0.081 multiplied by t, which we don't know, plus 20. So we are looking for the value of t. How do we solve this type of equation? Let's very quickly remember how do we solve equation when we are looking for a power, meaning that our letter is in power. Well, there are three ways of solving it. One, we have to get our equation to the form base power equal product, with meaning nothing in front of the base. And when we have it in this form, then we can apply log base product power. When we are looking, the second way we can solve it is if our equation gets to a place where you have base power equal, on the other side the same thing, base and power. And again, the key thing here, no numbers in front of it. And then if in this situation these two bases are the same, so if base equal base, well, therefore we can equal power to power. And that's how we can find the value of the letter in the power. And the last way is by substitution. What do I mean by that? Let's say in the equation we have 5 to the power of a. We substitute that with x, because in that same question we're going to have 5 to the power of 2a, and that will become x to the power of 2. So that's the three ways. Those two are less likely, they are rare when it comes to a question like that with the story. The more will appear in a pure algebra question, while in the question with the story, usually this is the approach. So back to our calculation. So we have 82 equal, so we identify that's my base and that's my power, so I need to have them on 75 has to go, 20 has to go. So the first thing, what do? We move 20. Now, to make that clear, I can divide both sides by 75 first. Makes no difference whatsoever. But easier to move first the numbers, that's why we move the number to the other side. And what happens when we move a number to the other side, we change the sign to the opposite. So from plus 20 becomes minus 20. 81t. Then the next thing, 75 to go, it's a multiplication. How do we eliminate multiplication? By dividing both sides of the equation. So we have our number here, and yes, you can put that in the calculator and find the value. Just be aware, if it is a decimal, rather keep it in fraction. So here we have our base, our power, and that number here that equal our product. So that means we apply the log, we take the base, we take the product, and that equal power. So applying that here, we take the log, we take the base e, we take the product, whatever that value is, and then that equal our power. Now, I want value of t, not t multiplied by a number, so that multiplication has to go. To eliminate multiplication, what do? We divide and divide both sides of the equation. And now we can put that in the calculator, so log shift e, our fraction 82 minus 20 divided by 75, and then divided bottom of the fraction minus 0.81. So 2.35, what are the terms and conditions of our answer? Give it to the nearest second. Time here is measured how? In minutes, so we have 2 minutes. And how many seconds? Well, not 35, that means is 0.35 of a minute, that is 60 seconds. So to get the second, we multiply that by 60, therefore 21 seconds. That's the proper time. Okay. And then next part. So like I'm saying, up to this part, if you are fifth year, that's how far you should go. Part C then will be specific for the 6th year because we are entering calculus area. Find to the nearest degree the temperature of the coffee has reached. So we are looking for the temperature of the coffee that coffee has reached. At what point? When? Then they are giving us that. What's that? T prime, that is what? The derivative of our function t. And they are saying when the value of derivative is minus 4.05, where t is at the rate which the coffee is cooling in Celsius per minute. Okay, so what are we looking for again? Temperature of the coffee. Now, how do we look for temperature of the coffee in this question? Well, we have the formula, isn't it? Temperature of coffee, and that equal my 75 multiplied by E minus 0081, and then number of minutes, and then plus 20. Okay, we already understand that, okay, if I'm looking for temperature of the coffee, that means that I need number of minutes. They haven't given me number of minutes. What they have given me is a value of derivative. How is the value of derivative going to help me to find the number of minutes? Well, if I'm going to have a function that represents derivative, or let's say our derivative, what two values, two letters that derivative is going to have? Well, it's going to have temperature, and it's going to have number of minutes, isn't it? It's going to have those two in it as well. So what do I get now? Here they are giving me value of that temperature, therefore I could find the number of minutes. And actually that number of minutes is going to be exactly the same as here. Now let me explain. So let's go here. Here we have the graph. So I want to show you that on the graph so that you can see that connection between derivative and the function. So this function, so here is our t. It should be red because our number of minutes is red. So that's our t. And here we have our capital T. This function, that's the t function. However, this function here, that's the derivative function. Like I said to you, the main function, our main function has two letters, t and small t. It will be the same here, big T and small t, isn't it? Because it's between the two axes. So they are saying that we are looking for the temperature of the coffee. So I'm going to read that somewhere here. When the value of derivative, meaning what? The big T is minus 0.5. So where am I going to have this value? Well, this is minus 20. So somewhere here is going to be minus 4. So it's going to be somewhere here. This is going to be my point that I'm actually looking for. This point has two values. Has a value of small t, and in our case, we know has the value of y. That's the value of y. Now, that same point here, that will be the point that I am looking for the temperature. They are connected with the value of t. T will be the same. The big temperature, I don't know. I'm going to read that from here. But that is the same. They connect by the t value. The connection between derivative and the main function always goes by the x value, the independent variable. And here as well, that will be the same true with tangent. If I had a tangent at that point, because sometimes in your question you're going to have tangent, that tangent is going to have the same that point where it's going to be touching it, it will have the same coordinates. It will be a common point between the tangent and that graph. Now, where am I going to have a connection? The slope of that tangent. So the slope will be value of derivative. So it will be that value. That will be the value of that, the value of the slope of that tangent will be the value of derivative at that point. Now, again, all of them connect by value of t, meaning independent variable. Hopefully I didn't confuse you, but hopefully I did help you to see that connection. So in order to find that temperature, I need the number of minutes, and number of minutes I'm going to get from the formula for the derivative of our t function, because I have the temperature here. Okay, so let's create derivative of our function. How do we do that? We go to the tables and we look for the formula. So we go to calculus, and there it is. So we are looking at our equation. How does our function look like? That is e, and then the power is just a little bit more complex than x itself. So let's get that. We know that we are deriving each term, so that's one term we are deriving, that's the second term we are deriving. So in our, let's make that bigger so that we can apply. So we have 75. What's going to happen with that 75 that is here is going to cross over. I'm going to have 75, then I have e, so that e, then I have a, that number that stands beside variable 008 minus 0081, and that's where it will go, and that will be t here, so minus 081, and I'm going to have minus 0081 here. That's the way we're going to change that. So our derivative, let's write it, t prime t will equal 75 multiply by minus, not 0, minus 0081 multiply by e to the power of minus 081 t. What happened with 20 will go into 0 in the process of differentiation. So now I know the value of it, minus 405. I know that I'm looking for this t when this t here is minus 405. So I put that into my equation. Again, what am I looking for in this equation? Letter t is in power. So I have my base, I have my power here. I just need to eliminate these numbers. It is a multiplication. How do I eliminate multiplication? By dividing, and dividing both sides of the equation. So that goes. So we have minus 405 over 75 multiplied by minus 0.081. One thing that we, just as a reminder, what do we have to be careful about the logs? Because here we have our product, our power, and base power and our product. So we're going to apply the logs. The only thing before we apply the logs, we always have to be mindful that log will not be defined for a negative product or 0. Here our product is not going to be negative because I'm dividing a negative number by a negative number, so that's going to be a positive. So log of the base of e of the product, and that equal my power, and again I want t, not t, with that number multiplication. I eliminate the same way every time I divide, and divide both sides of the equation. So log e, my fraction, minus 405 divided by 75 multiply by minus 0.081 and divided by minus 0.81, and that equals 5057. So t is 50057. We have now what? The time, that value, that number of minutes that we wanted, so that we take it here. And if we go back to our graph here, that's what it is. You can see that that is at 5. Yeah, and the temperature, you will see it will be as well at this value here. Where are we? Here we are. So we are taking that back to our original function because that's what we are looking. So I'm saying I'm looking for the value of t when that is the value of small t. T and t, too many t's. And it's not really about the tea, the question is about coffee, not tea. 5, 7 plus 20. So we put that in the calculator. 75 multiply e to the power minus 0.081 multiplied by 5.00, too many zeros, 57, and then plus 20. So 70. Temperature is 70. That is the temperature when rate of cooling is minus 405 minutes per degree. Okay, let's have a look at next part of this question. Okay, and the last part, a sugar cube is put into the coffee. Okay. A sugar keeps its cube shape as it dissolves. I'm sure we all seen that. As the sugar cube dissolves, its volume decreases, important word here, at a constant rate of 120 centimeter cube per second. So we do understand that the volume of that cube is decreasing because we can see it's less and less sugar as it dissolves. Let xt be the side length of the cube at time t. Therefore, find the rate of change of xt when the volume of the cube reaches 1/64 centimeters cube. Okay, let's take it and let's break it. Okay, so what are we looking for? Well, we're starting with what we are looking for. We have to find what rate of change. Well, rate of change means derivative. Derivative of what? Of xt. And not just find the derivative of xt, we have to actually find the value of that rate of change when volume is 164. So I'm looking for a derivative of xt function when volume is 1/64. Okay. Looks complex, but not really. So normally, how will we find a derivative and therefore value of it? Well, we will take function xt and we will create derivative of it. But here in this question, we don't have a function xt given to us. But what do we have? We have value here, and what does that value represent? It represents the volume decreasing at a constant rate. So that's our derivative given to us. Derivative of what? What kind of derivative is that? And the key, it's always very easy to decipher when we look at the measurement, is centimeters cube. Centimeters cube represents what usually in maths volume, and second represents the time. So this derivative that is given to us has to do with volume and time. Now, and that's why I said the word decreasing important, because that means the value of it is minus 1/20 centimeters cube per second. And believe me, it's easily to overlook it. I did overlook it when I was solving this question myself. So if we are looking for one derivative, we have one given, then we know what are we looking for, chain rule, isn't it? That's what we're going to be applying here. Therefore, we need third derivative. How do we find that third derivative and what do we need? So let's have a look at our chain rule here. Let me show you what is, I think, an easy way of finding, applying the chain rule. I know it's maybe not, how will I say, a traditional way of teaching, but if you know me and see how I'm teaching, you know that not always I teach in a traditional way. So here what we have, I just need black color. I'm just going to change the way it is written. Okay, take a note. You have three elements here. You have du element and du element. Here, let's not forget is multiply. Then we have another dx element. And here we have the third element dv. Do you see that? Three elements. Now, we already have dx, then we have dt, and then we have dv. As you can see, each of them is twice. I have dx1, I have one of it, I have two of dt, and I have one of dv. So that means that the derivative I'm looking for will be dv dx. Now you ask me, well, how do I know it's not dx dv? Well, that means this derivative of what? Volume and x. What does dx represent? Side length of the cube. So this is a derivative of volume of the cube with independent variable x. How do we calculate the volume of the cube? If you think about it, because we don't have a formula in the table, but the volume of the cube, we know it is side by side by side, isn't it? That's the way we calculate the volume of the cube. And cube is peculiar in what way? That every side is the same. So that means that that will be x to the power of 3. So therefore we can create a derivative of that. Now, so the next thing we have to do is to create the derivative itself. How do we create it? Let me write out again our elements. dx dt is the one we are looking for. dv dt is given to us, which is minus 1 over 20. And derivative of that, dv dx, how do we find it? That's a very simple derivative. That's our application of x to the power of n. That becomes nx n minus 1. So 3 comes in the front, followed by x, and then 3 minus 1, that's to the power of 2. So we have the three of them, one of them I'm looking. So as you know, one of the derivative equal, and then 2 multiply. How do I know which one? Well, those that will have the opposite value here. So which two opposite value do I have? I have dx and dx. Yeah? So that means that my dv dt will equal dx dt multiply by dv dx. There it is. So let's put numbers in place of those derivatives. So minus 1 over 20 will equal dx dt I'm looking for, multiply by dv dx, which is 3x to the power of 2. I want this value. This has to go. It's a multiplication. How do we eliminate? We divide, and we divide both sides of the equation. So that means my dx dt is minus 1 over 20 divided by 3x to the power of 2. We can work that a little bit. We don't have to, but we can if you want to. And I will show you how to work that. If I have a division with a fraction, what do? I multiply and turn the second one upside down. So that means that my derivative is minus 1 multiplied by 1, that's 1, 20 multiplied by 3, that's 60, x to the power of 2. That's my derivative. So my dx dt derivative is minus 1, 60x2. Now that doesn't answer the question, isn't it? Let's have a look. I need to find a value of that derivative where volume is 1 over 64. Well, how am I going to put volume here? Well, volume equal what? X to the power of 3, isn't it? That's what volume equal to of that cube. So 1 over 64 equal x to the power of 3, because I need to have a value of x. How do I eliminate power of 3? Very quick reminder again, our product, base and power. So when I have product, that equal base and power. I take what? I'm looking for the base, so I take my power. That tells me the number of the root. I put my product under it, and that gives me the base. So applying that here, that means it's going to be a cubic root out of 1 over 64. That gives me the value of x. So 1 over 64. So that's 1 over 4. That's the value of x. So that means what I'm looking for here is the value of my derivative. And I'm saying to myself, well, when volume is 1 over 64, that gives me x of 1 over 4. So therefore it's minus 1 over 60 and then 1 over 4 to the power of 2. And let's see, what do we get? Should be minus 1, 60 multiplied by 1 over 4 to the power of 2. So minus 4 over 15, minus 4 over 15. That's the rate that I'm looking for, centimeters per second.